Hi everyone, welcome to the channel. Today we're going to solve Leetcode daily challenge, problem number 787, cheapest flights within K stops. So the problem statement states that there are n cities connected by some number of flights. You are given an array flight where flight of I has three values in it from, to, and price, which indicates that there is a flight from city to a city with cost. Okay. You are also given three integers, source, destination, and k. We have to return the cheapest price from source to destination with at most k stops. If there is no such route, return -1. So this is the problem statement, and they have explained it very beautifully using few examples over here. So you can definitely, you should definitely check out the examples. So the first thing which came to my mind was to use like Bellman-Ford-Dijkstra's algorithm for this kind of a graph solution, like shortest distance between the graph solutions. But I wanted to opt for the easiest solution which I could have, which I can use, and I came up with a BFS solution to solve the problem. So what we are going to do is we are going to use BFS to tackle with this problem, and what we will be essentially doing is we will create a agency matrix in which we will keep a track of all the neighbor cities which I can travel to from a given point or from a given city with their prices. Okay. So as soon as we'll have those adjacencies, next thing we'll have to do is we'll simply put in a loop such that the loop runs either less than or equal to the given k, which represents the number of stops. Okay, this yeah, like which will represent this, or until we just process all our nodes in it. Okay, and if, for example, for this node or for this city one, if I find any way to reach this city with the smallest or the lowest price, I will update my value into it. Also, one more thing, I'll be using one more array to store the prices to reach to a city. Okay, so this is it. And at the last, like once we are done with everything, we will check if there was any way to reach to a particular city or to the destination we wanted within k stops. If not, we will return -1. If yes, we will return the value of it. So let's start the solution. Okay. So first thing, I wanted to create a agency matrix, right? So let's say it's ADJ, and I want to initialize it with lists. Okay, so that we don't get any key errors. Okay, so that's why I've used this default dictate. Now from so basically we have to iterate in flights. Okay, I hope I haven't made any typos. Yeah, this is fine. And in each value of this array, we will receive three values: local source, local destination, and local price. Okay, these were the three values in each element of the flights array. Once we have this, it's very simple. I wanted to add that in the nodes which I can visit from a given source. Okay, and we want to store both, like the distance, destination and the price. So yeah, this is it. Okay. Next comes the part where I wanted to have a array which will represent the minimum price which is required to reach to a particular destination or particular city. So let's name it distance, and let's initialize it with float infinity. I wanted to keep it as like the value should be as greater than as greater as possible. So I have used infinity, and I want to initiate or I want to update the value to the source as 0, because obviously we are at 0 and we need not to spend anything to reach to that point, right? Next comes the queue which I'll be using my uh, for my BFS, right? and we will initiate it with source and 0 as a value. Next come the stops. So this variable will help us to keep a check on the loop which we'll be using. So next comes the main part in which we will be checking the prices, and we will make sure that we run that loop less than or equal to the k. So while stops is less than or equal to the given an acceptable number of stops, and until we have values in queue. I want to execute this loop. So if any of this condition, gets false, we will just terminate this. Next thing is like we are using BFS, so we should check for the current number of elements in the prepared queue, right? So for that, let's say we are using size variable and length of queue. Because what we'll be doing is we will be appending the neighbor elements in the same queue. So there might be a situation like it will cause some issues in updating the number of stops, right? So that's why we have just we already took the size of the queue, and we will make sure that we are following the BFS approach. Next thing is just run a simple loop for all the elements in the size. Okay. Okay. Next comes the part where I want to process my value from the queue, right? So basically, we are storing two values in it. First one is the source at the current source which we are at, and the price it took to reach to that source, right? And this pop zero will basically remove the element from the starting of the queue. Okay? So we have initialized two variables, current source and source price. Basically, price we have to pay to reach to the current source. Once we have this, I want to check what all nodes or what all cities I can reach from my current source. So we'll have to use this agency matrix. So for basically for current destination, and we will get of course like we'll get two values from this as well. Destination which we can go and the prices. Uh, Destination price and agency of source. Okay. As soon as we are like we get these two values, what we need to check is if my source price plus destination price is greater than current price at the destination. So basically, if my current system or the current value is greater than, or I am paying uh, much more than what I have already seen, or what we have already seen using some other route to reach to the destination. If that is the situation, I don't want to continue with this loop. So if price we need to spend to reach to the source, and after adding the destination price, if this is greater than or equal to my current pricing to reach the destination, I want to come out of this loop. Okay. Next thing is if this condition is not true and if the pricing is low, then I want to update my current price with the new value and I want to update the element in the queue as well. Queue dot append, and we need two values in it, right? So the two values will be distance, like oh sorry, destination, current destination, and the amount which we need to spend. Okay. Once this is done, I'll come out this loop and I'll increment my tops with 1. So our loop is also done. Like we just need to return the value now, like return the price it will take to reach to the given destination. Okay, so just a sec. To reach to the destination, I want to return this if the value in my distance array or the price array is not equal to like my initialized value. Okay, otherwise I would return -1. So this condition will be true if there is no path to reach to the destination. Okay, or no path to reach to the destination with the given or within the given number of stops. So let's check out the test cases. Yeah, so the test cases got accepted. Let's submit for further evaluation. Okay, there is an issue. Just a sec. Output didn't match. Okay. Output should be 10. Sorry, expected was 7 and we did 10. There must be a condition which will be missing. Destination. Okay, let's just check the whole code once. Source, destination, file, and we are opening that for all the sources. That is good, I think. Initializing my distance with a infinity, that's fine. Now Q is where top is 0, destiny equal K and Q is there, okay, size length of Q. I'm running that in range. I am getting my source and price to restore from Q, top 0, that's fine. Then I'll receive my destination and the price we need to reach the destination from current source. If source price plus destination price is greater than equal to distance to reach my destination, I continue. Otherwise, seems fine to me. At the last, I am implementing my stop step point. That is also good, I think. Uh, mm, Not sure where we have missed the code. 0 and 5, okay, goes to 2. Okay, so 5 and 5 software. Okay, 5 plus 1 plus 1. Like this should have been the output, but k equals to 2. Hmm. Okay, okay, okay. Okay. So after a while, like I found the solution, like I was missing one condition in it, so that's fine. So finally, like the solution got accepted and we performed really well. We outperformed 85.3% of the submitted solutions. So yeah, thanks again guys for watching out the video. Don't forget to subscribe to the channel. Thank you.